Good morning, all of you. In today's session, we are going to start with the 10th class chemistry and physics, unit 4, refraction of light at the curved surfaces, series number 7. Earlier, we completed series number 1 to 6 and all detailed explanation available on the channel called World of Competitive Chemistry. In addition to this, we are also completed unit number 1 to 3 and even unit number 5. All completed explanations are available on the channel called the World of Competitive Chemistry. Now let us enter into series number 7 of this unit 4. Here, in order to draw the ray diagram, certain guidelines were framed. This is in continuation to our previous series number 6. Right. So in order to draw the ray diagram, certain rules or guidelines are formulated. Let us discuss about what are the guidelines we have to follow here. In order to draw the ray diagram, to find the position and the size of the image, we have to obey certain guidelines which are provided in 4 different situations. In order to mention the size of the image and also position of the image, here 1 to 4 guidelines to be obeyed. Those are: select the point of object. Where you are placing the object, that is the most important thing in order to predict what will be the size and what size as well as position of the image going to be generated. So select the point of object on the principal axis. This is the fundamental criteria. And the second is about draw two rays whichever chosen by you from the rays mentioned in the situation 1 to 4. 4 different situations were mentioned. All are obeying these 5 rules. So with these 4 situations, you are going to draw the 2 rays from the object 1, so that you will get different kind of images. This is the second condition. And third is about extend both rays to intersect at a particular point. This point gives the position of image. Wherever the convergence of the lines are possible, there only image formation is possible. This is another fundamental thing. And the next is draw the normal from the point of intersection to the principal axis. Okay, so dotted line should be extended towards the principal axis in order to connect that intersected point with the principal axis. That point is said to be a normal, and the length of this normal represents the size of image. What normal you are drawing, that will be the size of image. Sometimes it may be exactly similar to the object, some other time it will be diminished, and some other time there is a possibility of enlarged one. These are the 5 rules we have to obey in order to get the image in the ray diagram. In brief, we will discuss one more time. First one, we have to select the position of the object on the principal axis. Second is 4 situations should be obeyed in order to draw the 2 rays from the object, and these rays are used to intersect at a particular point where the lines are used to convert that point used to generate the image. Right. So from the image point of view, you have to extend, you have to connect with the principal axis. That is said to be a normal. Right. So the normal which represents the size of the image. If the normal size is very large, you can say enlarged size of image will be possible. If the normal is very shorter in nature, so that concised image will be generated. These are the 5 rules in order to draw the ray diagram with respect to either concave or convex lens. Generalized principles are provided. Now we are going to apply 4 different situations to employ these 5 rules. First one is about object at infinity. Right, we kept the object at infinite distance that is not known exactly. Right, beyond the center of curvature, that object was kept. In the case of object kept far away from the almost infinite distance, far away from the lens, it was kept. So we draw the rays parallel to the principal axis. So when it kept infinite distance, all the rays are moving in the parallel direction and going to be heated on the surface of the convex lens. This is said to be a convex lens. Later, they will participate in the bending called a refraction and used to associate at the point called a focal point, which is called a focus. So in this manner, when the object is this infinite distance, all are in the parallel motion and moving in this direction and converged at the point called a focal point. This is the condition 1. Then what type of rays fall on the lens? In case of this one, when object placed at the infinite distance, all the rays are parallel in nature. That is the exact answer what we are asking for. Right. So if the object is at infinite distance, all the rays are said to be parallel in nature and they used to travel similar direction with respect to the principal axis and used to converge at the point of focal, right? And you know that the rays falling on the lens from the object at infinity are parallel to the principal axis. All the rays are parallel to the principal axis and object when placed at infinite distance. Now, they converge to the focal point and the point-sized image is formed at the focal point. So, where the convergence is there, there only you will get image of the object. So, here at the focal point, you will get the image of the object. This is the condition number 1. Let us apply situation number 2. Object placed behind the center of curvature on the principal axis. Just behind the center of curvature here, you can clearly observe object was kept. So on the principal axis, it was kept. As shown in the figure 13, you notice that when the object placed behind the center of curvature, it will be real image. Here you can observe the image. So image will be generated in between center of curvature and focal point. In between center of curvature and focal point, you will get the image that is a real image because it is generated on the screen, and you can say it is inverted. So object is vertical upright and here the arrow is descending towards the downward direction. That's the reason why you can say it is the inverted one. And when compared to the object, it will be smaller in nature. Small size image was generated. That a small size image is nothing but diminished image is generated. This will be originated in between center of curvature and the focal point, right? So this is figure number 13. So figure number 13, we have chosen two rays. Two rays were taken here. One ray passing parallel with respect to the principal axis. This is the principal axis. On this center of curvature, we have focal point, and again center of curvature, focal point was taken. And here is the mirror. What is the mirror? Double-headed arrow indicates what? Double-headed arrow indicates convex mirror it is, right? So one of the line is exactly parallel with respect to the principal axis, that is the upper one, and lower one, it is moving with certain angle. It is moving with certain angle and crossing the optic center. This is crossing the optic center. Later, these two light rays involved in refraction and will be converged at the point called this convergence point, and you are going to draw the normal, and you can find the image of this one. This is about the second condition where object was kept just beyond the center of curvature, and two light rays, one is a parallel, second is a crossing through the optic center, so that here convergence point image formation, the image formed will be real, inverted, diminished one is generated. This is condition number 2. Let us think differently and try in the different manner. You're going to try in the different manner. And what is the condition we have to follow? One passing parallel to the axis. One is passing parallel to the axis, and second through the focus. One is with the parallel to the principal axis, and the second is passing through the focus point. And they're asking to draw the diagram. This is about the drawing of a diagram for this condition, what they are asking for, right? So this will be the ray diagram for one of the light rays. So let us assume this is the point of object, where one is the straight parallel line was drawn with respect to principal axis, and another line which is passing through the focus and intersected on this lens, so that image is formed at the distance A prime and D prime, right? So this will be the virtual image generated at this point of view, right? So this is another question they are asking in the different manner. Let us move on to another condition we are going to apply. Object placed at the center of curvature. So in the third condition, exactly at the point of center of curvature, the object was kept. And again, we are going to draw two lines. One is parallel, second is crossing through the optic center. One is the parallel line with respect to the principal axis. Second is passing through the optic center, and that used to converge exactly at the point of center of curvature again. So center of here, in case of concave or convex, biconcave and biconvex lens, you can obtain two center of curvatures. At the point of center of curvature of one side, you kept object. In the same distance, you are going to get the image on the other side of center of curvature. image is inverted, but the size of image and object will be exactly similar. What is the distance of object and exactly similar distance of image? Similar height of the image is generated, and being it is real image and generated on the screen, it will be on the same. It will be of the same size but inverted in nature. This is the condition number 3 we are going to apply. What's the condition number 3? If the object placed exactly at the point of object, at the point of center of curvature, and again you will get the image exactly at the center of curvature of another side of this convex lens, right? So here, when two light rays are allowed to pass through this, so one is from the tip point and moving in the parallel direction with respect to principal axis. Second is moving with a certain angle and crossing this optical center. Both are refracting, bending when passing through the solid lens, so that they used to converge exactly at the point of center of curvature, and you will get the same size real image. What we can say, real image same size but inverted one is obtained. This is the condition number 3. Let us apply condition number 4. Object placed between center of curvature and the focal point. Just we are moving forward, so that center of curvature and the focal point, in between we are keeping the object, so that again two light rays are allowed to originate from this object, and one is parallel, second is crossing through the optical center, and image formed beyond the center of curvature. Image formed beyond the center of curvature, and it is a larger enlarged one. You can say it is a kind of real image. You can say it is a real image inverted, magnified, size will be an enlarged one. So this is a condition number 4. These are the conditions, and we are going to apply another condition. Object located when we are keeping object exactly at the focal point. Object when placed exactly at the focal point, the image will be formed. Again, you are going to get two rays of the light. One is parallel axis, second is crossing the optical center. Image formed will be at infinite distance. You are not able to see the image if object was kept at focal point. So image at the infinite distance. That's the reason why we are not able to measure their properties. What is the nature, whether it is inverted or vertical upright. Otherwise it is a real image or virtual image. Otherwise it is larger or shorter, anything. So no such kind of discussion about the nature of image, because it is formed away from the viewer. So at the infinite distance it will be generated. So nature of the image cannot be predicted in a clear manner. And let us move on to last condition what we are going to apply here. Object kept very closer to the optical center beyond this focal point. Here center of curvature is there, here focal point is there. We kept away from the focal point. So very near to the optical center this object was kept. This is the condition number 6. Object placed between the focal point and the optic center. Between the focal point and the optical center, so that this what object used to generate two light rays, and they are moving and they are reflected back and used to converge at the point of focal point, and image will be generated. Image will be generated. What's the condition here? You can clearly observe the image formed at the distance. When you compare the size of object and size of image, it will be multi-folded sized one, right? So here exactly at the focal point you will get the image that is a larger one, but it is a virtual, because it is formed on the mirror, not on the screen. So that you can say it is the virtual image formed. So this is exactly at the focal point. The size of image is larger than that of object, and it is said to be a magnified image. It is said to be a magnified image. Then what will be the direction? What is the direction of object? Same direction of image is formed. Vertical upright, you can say it is erected one. It is a erected one. This is the condition number 6. How many situations we applied? Let us combine all the 6 situations in a single term. In the first case, you are placing the object at infinite distance. You are able to get the image at the focal point, right? And the second condition, object placed just beyond the center of curvature, and the image formed just in between the focal point and the center of curvature in the inverted manner, diminished one. This is the second condition. And third condition, exactly at the point of center of curvature, if object was kept exactly at the center of curvature, the image was formed. This is the condition number 3. In the condition number 4, object was kept in between the center of curvature and focal point, and image generated beyond the center of curvature, and the enlarged magnified image will be generated. Condition number 5, exactly at the focal point, image generated at the infinite distance whose properties are not possible to measure. And the last situation, that is condition number 6, object placed between the focal point and the optical center. This is far near to the optical center, so that image formed will be on the mirror, virtual, and the magnified, extremely large sized, many folds increased size of the image was formed in this condition. This can be employed. This is a real-time application in our life, that is the microscope. So we are going to draw the inferences from this one, right? So object placed between the focal point and the optic center, this is the most fundamental, most important thing. So in case of this one, we have plenty of applications, because it's a very important. If the particle is not visible to our eye, by using this kind of lens and this kind of condition, it is possible to observe in the larger size. In the larger size, by using this magnifying lens, otherwise by using this microscope, and even binocular also working. So in this way, situation number 6 having multiple applications in our daily life, right? Let us see what are the inferences drawn from this situation number 6. What are the inferences? As the image forms virtual, we can see with our eyes. Virtual image can be easily visible to the human eye, and in all other cases, image will be real, except the situation number 6, remaining all are the real images, can't see, and it is not possible to see. They are available on the screen, and separate aids are needed in order to visualize them, and our eye cannot capture them, right? So this situation number 6, where the size of the image was enlarged in the larger extent, so that it will be easily available to see that. A magnified virtual image is formed on the side of the lens where the object is placed. So where we are placing the object, in the same direction you are getting its image also. That image you are seeing through the lens is not a real one. That is a virtual one of the object, right? So here virtual image formed, and the same side with respect to the object, you are getting the image also. These are the inferences drawn from the situation number 6. Now we are going to observe the practical application of this convex lens, especially situation number 6. In the above two inferences, there is a peculiar behavior for convex. As of now, all the situations mentioned, all 6 situations mentioned applicable to this convex lens only, right? So in above two inferences, peculiar behavior of convex lens help us to construct the microscope. So based on this situation only, we invented this microscope, where magnified image is generated. The microorganisms of bacteria, virus, algae, fungi, protozoans, whatever, those microorganisms cannot be visible to our human eye. They are present in the air, water, in our intestine, wherever you want to check. In every region of this atmosphere, you can find those microorganisms. In order to understand, in order to study them, a microscope is very essential. And even nano-sized particles and another micro-sized particles can be easily visualized by using this microscope. Till now, we have drawn ray diagram for the various position of the object placed on the principal axis using convex lens. Now, is it possible to draw the same type of diagram by using concave? We are going to replace convex lens with a concave lens in between center of curvature and focal point. So let us consider the object kept in between center of curvature and the focal point. In between these two, we are keeping object, and here the lens used will be concave. Concave means curvature will be there inside for both the sides. That is clearly mentioned with the symbol. This is called concave lens. Curvature is there inside, right? So verify your ray diagram with the ray diagram we have drawn in the figure number 18. The figure number 18, we are drawing the diagram. Concave lens was taken, and here this center of curvature and focal point in between object was kept. Then what kind of inference you are going to draw? Again, two rays of the light were originated from the object. One is parallel with respect to the principal axis. Second is bisecting this optical center. Try to draw the ray diagram for the position of the object. You will notice that irrespective of the position of object and the principal axis, you will get the erect virtual diminished image. Here you can clearly observe where the image formed in between the focal point and the optical center. So it's very clear. Image is represented here. That is the shorter one. When compared to the object, it is very teeny, right? So shorter image is formed and it is a virtual. Why you are saying it is a virtual one? Because it is generated towards the object only, not opposite to the object. That is nothing but which is formed in the mirror, but not on the screen. So it is a virtual image. And what is the direction of object? In the same direction, image is also formed, but in the shorter size, right? So in between the focal point and the optical center, this image was formed with this concave lens. This is a condition we are going to apply, right? Then yes, let us apply some examples in continuation to these rules and applications, right? So rules were framed. According to those rules, we drawn different inferences. Based on that, we are going to practice the examples, right? Draw the ray diagram to locate the position of image when the point of source is placed on the optical axis MN of the convex lens in such a way that it is beyond the focal point as shown in the figure. So let us discuss in the detailed way. So this is a ray diagram. Ray diagram is nothing but from the object, what are the rays generated? When they are passing through the lenses, what will be the change in its behavior? That is nothing but a ray diagram. We are plotting the ray diagram and the position of image when the point of source. Source is nothing but object to source. Object to position is called a source, that is S. And we kept a convex mirror here. And so here, what happens? Optical axis MN. So here, principal axis now said to be a optical axis. So within this example, they are mentioning this as an optical axis, which is simply known as the principal axis only, right? So here, convex mirror was placed when this is a source. And what will be the position of image? What will be the position of image that to be predicted? Then, what is the position of this position of the point source? That is in between focal point and center of curvature. Away from the focal point, here this point source was kept. Then, so when we plot this diagram, what are the inferences we are used to draw? Draw perpendicular line to the principal axis. So this is the principal axis, right? Principal axis is nothing but the line which used to moving with the center of curvature 1 to center of curvature 2 is called the principal axis, passing through the focus point 1, right? So here, what we are doing, we are plotting the graph perpendicular to the principal axis passing through the focal point. So perpendicular to the principal axis, we are going to draw a line. Draw a ray from the point source S in any direction to meet the lens at the point P prime, right? So here, one of the line is exactly on the principal axis we drawn, and the second is in order to bisect this P prime, another light ray was drawn, and that used to bisect on this convex lens. Now, draw another line parallel to the ray diagram and the point of source such that passes through the optic center. Just now we discussed. So one is passing through the optic center, second is passing through the P prime. P is the optic center, P prime is the another line which is drawn on the concave lens. So with certain angle it is moving. So two light rays are originated from source, point source, right? So here this line intersect at the normal FO. So this line is used to intersect at the line FO. So here it is clearly mentioned FOE on this principal axis. So away from the principal axis, this line was kept. Now, draw a line passing from the PI draw a line passing from the PI to pass through the FO, and it used to cross the FO point such that it meets the principal axis at the point I. So what we are doing, we are originating the ray from this S point and used to bisect the convex lens at P prime. Later, it used to travel and used to cross this F naught and meeting the principal axis at the point of I. So this is about one ray diagram. And next, I is the image point of the point source. This is the point source. This is the point source. From this light rays moving, and ultimately where the convergence is possible, there you are going to get the image of that one. Here you will get its image, right? Now complete the ray diagram to show the path of rays which refraction through the lens as shown in the figure. So this is the way we are going to plot the diagram. So for example number 4, so in simple way, we are going to discuss one more time in order to get the complete picture. This is the principal axis where center of curvature to center of curvature it is meeting, and S is nothing but object source where we kept object at this position. One of the light ray is moving with certain angle, another light ray moving in the regular path of principal axis. So this light ray of angle is bisecting the convex lens at P prime and passing through the F naught and reaching the principal axis at the point I. And in the similar manner, the straight line which is originated with respect to principal axis also meeting at the point of I. Where the convergence is possible, there the image formation is possible. This is the condition number example number 4. Now let us move on to example number 5. Complete the ray diagram to show the path of rays after refraction through the lens shown in the figure. E phi A, E phi B. So these are the partially drawn diagrams. Partially drawn diagrams are given. We have to extend these diagrams to complete the ray diagram. So what is the diagram? In this case, what you are taking, this is the principal axis which is starting from center of curvature to ending with center of curvature. And 2 focal points also mentioned on this. And this is a mirror called convex mirror. And a light ray is moving in this direction, and either light ray is moving in this direction. This is the condition number 1. Now condition number 2. In condition number 2, we are applying concave mirror, and this is the principal axis, and center of curvatures are denoted on this, and focal point 1 and focal point 2 also mentioned here, and a light ray is moving in this direction reciprocal with respect to E phi A. So it is above side, it below side. So here also ray diagram we have to complete. In order to get this, follow the steps mentioned in the example, complete the ray diagram. So whatever rules we just discussed, same rules can be applied to this one also. So when we apply same rules, here complete a diagram of that one is represented in these two. So for phi A extension, that means completion will be given in phi C. Phi B completion will be given in phi D. Let us see how it is possible. So when we are keeping our object away from the focal point, right? So that used to give the 2 light rays. One is reaching at the point of convex lens at this center and bisecting this focal point, and that will be reaching this principal axis at this position, and another light ray is also moving in the parallel direction, so that the convergence is possible at this position. So image will be formed at this position. So this is the position of image. This is the condition number phi A get completed in this manner. Then let us complete phi B. What happens? Light ray is moving in this direction, another light ray is moving in this direction, parallel with respect to the principal axis. So exactly on the principal axis, and moving through this concave mirror. Concave mirror, what happens? It used to reflect back. It used to bounce back in this direction, and from this normal we are going to draw the diagram, and another light ray is moving in this direction, and the principal axis will bounce back in this way, and here the convergence will be possible. So this focal point is the exact position. This focal point is the exact position of image. Image will be generated at this focal point. So this will be the virtual one. And in condition number E phi C, it will be the real image. In condition number E phi E phi d, it will be the virtual image. So in this manner, we will get a ray diagram for the various conditions. You will notice that paths of rays are shown in the figure E phi c and E phi d. So these are the paths. One is moving in forward direction, second is reflecting back, and at the focal point, there is a convergence is possible and the virtual image formation is possible, right? And can we realize that in practice, the results obtained in the ray diagram when we perform experiments with the lens? So these are all are the theoretical assumptions only. Then is it possible to draw them in the experimental manner? So we have to go for the experimental conclusions. So theoretical assumptions, rule of framing, everything completed. In the next series, we are going to extend with the laboratory activity of all these theoretical assumptions. Hope this session will be helpful for your preparation. Thank you very much for your consistent listening. Thank you, one and all.